Now let us see how to solve using Gauss-Jordan method. So here for Gauss-Jordan method, we have to consider the same augmented matrix AB like this, and then here we have to convert the matrix A to an diagonal matrix, whereas in Gauss elimination method we have to convert the matrix A to an upper triangular matrix, whereas in Jordan method we have to convert it to an diagonal matrix, the matrix A alone. Okay, according to that we have to rewrite that formula, row operation. Okay, so since how to convert here to an diagonal matrix, as usual the elements below the diagonal and above the diagonal we have to convert it as 0. So already in Gauss elimination method we learned how to convert these two elements as 0, right? Similarly here we have to convert in the next step, we have to convert this as 0 in Gauss elimination, whereas in Gauss Jordan along with this element we have to convert this element also 0 using R2. Okay, so that what we can do here is first step we can follow as per Gauss elimination method, how to convert this and this as 0 using row operation. So 2 belongs to R2 and 3 belongs to R3, that is row 3. So this is the row operation we already used to convert these two elements as 0. So use the same row operation here to convert these two elements as 0. We have converted here. In the next step what we have to do here is we have to convert this element and this element as 0 using row 2. Okay, here we have used row 1. Similarly here we have to convert row 3 and row 1 element as 0. For that we have to use row 2. Okay, so now what is the row operation and how to write the row operation? So now to convert minus 7 as 0 using R2. So minus 7 plus 7 will give you 0, right? So here R2 is minus 1. So R2 is minus 1. So here minus 7 won't give you 0. So this should be minus here. So the formula will be, this is what? R3 minus 7 into this is R2. So this will be the formula for, or to convert minus 7 as 0. So R3 should be replaced as R3 minus 7 R2. Similarly, now for this element 2 in R1 we have to convert it as 0. So 2 minus, already minus 1 is here now. So what we can do, directly 2 minus 2 will give you 0. So into R1 means R1 is minus 1 here. So here we have to take it as plus. So this is R2 plus 2 R1 will give you 0 here. So the formula for R2 is, R1 is, this is R1, this is R2, this is R2, right? R1 and R2. So R1 is R1 plus 2 R2. So this is the formula to make or convert 2 as 0, and this is the formula to convert minus 7 as 0. Now you can use these two row operation and apply here. So while doing like that, there won't be any change in second row. So we can write the second row element as it is, right? First you convert R1, first row. R1 is what? 1. R1 is 1 minus 2 R2 is already 0 here. So directly 1 will come. And then here for 2, this only we made it as 0. 2 plus 2 into R1 is minus 1. Similarly for this element 1 plus 2 into 1. Similarly here 3 plus 2 into R2 is 4. Okay, similarly do it for third row. Third row it will be 0 only, because R3 is 0 minus 7 into R2 is also 0. So 0. Similarly here minus 7 is already there. Minus 7 into R2 is what? Minus 1. Similarly R3 is minus 1. Minus 7 into R2 is 1. Similarly here 4 minus 7 into R2 is 4, right? So close the bracket. So this you simplify, so that 1, 2 minus 2 is 0, 1 plus 2 is 3, 0 minus 1, 1, 0, 0 minus 8. Here it is 11, 4 minus 24. So this is the next step. Now how to convert it into diagonal matrix? Again we need to convert what this element and this element as 0. Now to make these two elements as 0, we have to convert this, that is using R3 we have to convert. To use R3, actually here it is minus 8. If you have the coefficient as 1 here, it will be easy for calculation. Whereas in the previous step already it was 1. So we took directly. But here it is 8. 8 will be, it will be complicated compared to 1. So first we can make this as 1 by throughout dividing this row by minus 8. That is, here additionally we can use one more row operation for R3, that is R3 by minus 8 we can do. Okay, so that this matrix we can write it like this. And here it will be 0, 0, it become plus 1 and then 3. So now it will be simple for a calculation. Now making this 1, we have to convert these two elements as 0. So for this, what is the row operation for R2? For R2, it will be R2 minus R3, because R3 is 1, R2 is 1. So directly if you subtract it, you will be getting 0. So R2 minus R3 is 0. Similarly, how to make this 3 as 0 again? R1 is equal to R1 is 3 minus 3 into R3. R3 is 1 here, right? So minus, this is R1 minus 3 into R3. So this will be the formula. So these two are the formula, row operation formula to convert it into a diagonal matrix. Now using this row operation, we can convert the remaining elements as 0. So here last row remains the same. We have to convert only row 1 and row 2 using this row operation. So using this row operation, easily we can convert it. So there won't be change over here. Actually we are using R3, because of the reason we are using R3. Here the coefficient are 0 and 0 here. So here these two elements, there won't be change. And this 3 becomes 0 here, right? Because 3 minus 3 into R3 is 1. So this gives you 0. Again, what about this element 11? 11 is 11 minus 3 into 3. So this is 2. So you put 2 here. Again for second row, this becomes 0. Again for 4, it is 4 minus R2. The formula is R2 minus R3. R3 is 3 here. So this is equal to 1. So directly you put 1 here. So that's it. So now using Jordan method, we have converted into directly diagonal matrix like this. So why we need to convert it into diagonal matrix? Means it gives you directly the value of x, y and z. So no need to go for back substitution method. So directly x equal to 2 minus y equal to 1 and z equal to 3. That is, again we have to convert it into system of equation, so that we will be getting the value directly. So we can write it finally that x equal to 2, y is equal to minus 1 and z equal to 3. So the difference, main difference between Gauss elimination method and Gauss Jordan method is, in Jordan method we have to convert it into triangular matrix, whereas in Gauss elimination method we have to use or convert it into upper triangular matrix, and then we have to use back substitution method. Okay, so likewise we can identify the value for the given system of equation.